Hi and Assalamualaikum. My name is Tengku Anis Maisara binti Tengku Masrun. My matric number is A21B3147. I will present about introduction and data description. For the introduction, the study of statistics involves mathematics and relies upon the calculation of numbers. It also relies heavily on how the numbers are chosen and how the statistics are interpreted. For example, the following three scenarios are interpreted based upon the presented statistic. It will find that the numbers may be right or may be wrong. It must identify a major flaw with each interpretation before describing it. Next, the two major areas of the statistic are known as the descriptive statistic, which describe the properties of sample, population data, and inferential statistic, which uses those properties to test the hypothesis and draw conclusion. Descriptive statistics include mean, average, median, mode variance, skew. Next, for the inferential statistic include linear, regression analysis, analysis of variance, which is ANOVA, and null hypothesis testing. The objective of this study was to learn how to collect data sets, describe the data sets using the descriptive statistic, represent data set graphically, and perform statistical analysis using IBM SPSS software. For the data description, a set of data usually comes from a statistic population of samples derived from actual observation, and each row corresponds to the component of the observation, which is the population. Subsequent data sets can generate of specific types of software for testing purposes by using SPSS software. Next, quantitative variables are those variables that are measured in terms of numbers. Based on the table above, quantitative variables are age, BMI, children, and charge, while scales of measurement of them are ratios. Besides, qualitative variables are those that express a qualitative attribute such as sex, smokes, and region when measuring of them using a nominal scales. This table shows that a statistic of data sets of life insurance charged with 1,338 observations by using SPSS software.
Sampling is a process of selecting several individuals or objects for a study in such a way that the individuals or objects represent the sample from a target population. So, the purpose of sampling is to gather data from sample to make an inference that can be generalized to the population. Probability-based sampling may be used to guarantee that no correlation exists between the points selected from the sample by assigning random numbers to points in the data collection. Sampling may also be non-probability based, in which case that analyzed judgment is used to choose and extract a sample of data. This research has two types of data. The first is numerical data. Numerical data is also known as quantitative data, and it is always collected in numerical form. So, the numerical data in this research is age, BMI, and charge. Second, categorical data. Categorical data is a collection of data that has been separated into categories such as qualitative analysis, graphical analysis, interval scale, numerical values, and nature. Our group recorded children as the categorical data. So, this is one of the data that we change into the numerical data.
Hello and hi, my name is Noshafini Irafa. My matrix number is A2A275. Today I will present about descriptive measures. In descriptive measure, we have three types, which is measures of center tendency, measures of position, and measures of variation. In measure of center tendencies, we have mean. To calculate mean, we can use the formula mean equal to fs divided by n. This formula we can use for calculate mean for good data and also ungood data. So mean for X is 39.50, BMI 30.15, for charges is 14,610.79 and children is 62.5. Second is median. To calculate the median, we can use the formula median equal to LM and divide by 2 minus FM negative 1 divide by FM multiply with C. This formula we can use for the good data. So for ungood data, we can use the formula median equal to M plus 1 divide by 2. So the median for X is 38.8, median for BMI is 31.85, and for charges 80,920.01, and for children is 8. And lastly, we have mood. To calculate the mood, we can use the formula LM plus data 1 divide by data 1 plus data 2 multiply with C. This formula we can use for good data. So mood for X is 24.3, mood for BMI is 28.9, and mood for charges is 5,921.78, and children is 0. In measure of position, we have quarter. To calculate the quarter 1 is the formula is quarter equal to LQ1 plus width and divide by 4 minus VF divide by FQ1 multiply with C. And to calculate the quarter T is Q3 equal to LM plus width TN divide by 4 minus VF and divide with FQ3 and multiply with C. This formula we can use for good data only. And after we know the quarter 1 and the quarter T, we have to calculate the interquarter range. The interquarter range we can use the formula QT minus with Q1. So interquarter range for X is 25.91, for BMI is 7.97, and for the charges is 30,718.3. And lastly, in measure of position, we also have range. To calculate range, we can use the formula maximum data entry minus with minimum data entry. This formula we can use in for good data and also for ungood data. So range for X is 42, for BMI is 32, and for the charges is 54,000. And lastly, in measure of variation, we have two categories. First is variance. To calculate the variance, we can use the formula S square equal to 1 divided by n minus 1 fx square minus with fx square divided by n. This formula we can use for good data. So for ungood data, we can use the formula S square equal to 1 divided by n minus 1 s square minus with s square divided by n. So variance for X is 166.97, variance for BMI is 33.32, and variance for charges is 135,2018,6,3016.9, and children is 2.86. And lastly, in measure of variation, we have standard variation. The formula is S equal to square root S square. This formula we can use for good data and also ungood data. So the answer for standard variation X is 12.92, for BMI is 5.77, and for charges is 11,631.24, and for the children is 1.70.
Assalamualaikum and hi, my name is Nuruzna binti Zulkifli. My metric number is A21A2991. So today I will present my part is graphically presentation drawing. We select 8 MBMI data set for graphical illustration. There are numerical data. So for the first graph, I choose a pie chart, a factor 8 with the label female or male to indicate introduce a smoker. So if you can see that the charta pie show that the percentage of figure 4.1 show that the smoker more than 61% is a male compared to the percentage female is 39%. So for the next graph, I choose the histograms, factor of BMI with a levels high or medium or low to indicate insurance a smoker. In this graph, we can see the percentage of a figure 4.2 show that the BMI will be affect the smoker more than lower BMI is the high percentage is 47% compared to medium and high is 25% and 28%.
Hi and Assalamualaikum. My name is Nurul Izzah Amira binti Mak Yusof. My metric number is A21B2996. I will be present about statistical analysis. Let's start with numerical descriptive measure. The first one is age. There is a difference in value between manual calculation and calculation using IBM SPSS software. The median, mode, range, standard deviation, variance and quotiles in manual calculation are slightly different in terms of values from calculation using software. However, for mean values are the same in this income data set variable. The shape of distribution graph is normal bell shape. Next is BMI. There is a difference in value between manual calculation and calculation using IBM SPSS software. The median, mode, range, standard deviation, variance and quotile in manual calculation are slightly different in terms of values from calculation using software. However, for mean values are the same in this income data set variable. The shape of distribution graph is symmetric. And the last differentiation is charge. There is a difference in value between manual calculation and calculation using IBM SPSS software. The mean, median, mode, standard deviation, variance and range values are different in terms of values from calculation using software in this income dataset variable. The shape of distribution is positively skewed. The last one on this part is graphical presentation using IBM SPSS software for categorical dataset. Chart for sex are based on question 4, which is drawing on paper. These are chart and frequency table for categorical datasets that have been selected and implemented in IBM SPSS software. It is shown that male is more than female. Next point is hypothesis testing. The t-test result shows that the mean number of age is less than 39.2. The ANOVA result shows that there is no significant difference among the treatments. The table shows the correlation of age, BMI and charge. The value of R indicate that there is a different correlation between age, BMI and charge. The correlation between price and income is 0.109, which is positively correlate, and this test shows a significant relationship. The strength of the correlation is weak. The correlation between age and charge is 0.299, which is positively correlate. This test shows a significant relationship. In addition, the strength for correlation is weak. The correlation between charge and BMI is 0.198, which is positively correlate. This test shows a significant relationship. Furthermore, the strength of the correlation is weak. With this, all three values are less than 0.3, which is close to 0. Finally, we can conclude that there is no correlation between the three variables. So the decision of Pearson correlation is accept. The confidence interval is the range of value over which a population parameter is expected to occur. Thus, the two widely used confidence intervals are 95% and 99%. 95% is the confidence interval for the sample, which means that the level of importance is 0.05. Thus, value is 0 and 95% different confidence interval mean level important A 100 minus 95% equal to 5%. Therefore, the mean average for age is 95.21. The upper bound is 39.96 and the lower bound is 38.45. The difference between upper and lower is 1.51. Next, the average mean for BMI is 30.6634, while the upper bound is 30.9904 and the lower bound is 30.3363. The difference between upper and lower is 0.9541. Finally, the mean average for charge is 13270.4223, while the upper bound is 13919.8505 and the lower bound is 12620.9540. The difference between upper and lower is 1298.9365.
By using the software prediction of modeling, we show that a model summary, the R square value is 0.47. That's mean 47% of the variance charts can be explained by 8 NBMI. The Durbin-Watson is a 1.08976, a little bit far from 2, which is 0.910. And then we show that the ANOVA, the p-value from the ANOVA table is more than 0.005, which is mean that at least one the two variables 8 NBMI. By table coefficients, construction regression model, which is the corporate in the variable of interest following the general from the multiplied linear regression. By using the formula, Y is a charge, BO as a constant, X1 as a H, X2 as a PMI, eta is a irritant. For the explanation, just for every unit increase in the charge, then it will be increased by 2.148 units, provided the level of charge remains the unchanged. Similarly, for the very increase in the units, PMI will be increased by 0.390 units. Based on the standard beta coefficients, the charge unit, the effect is 1.28903. So for the 39% coefficient interval, for the H is 38.45, 39.39, where is a value of 0 fall in the interval again. Indicate the 8 will be certification predictor. Meanwhile, 95% from CI for BMI is 8.114, 8.97, where the value of 0 fall in the interval, again showing the BMI is an important predictor. For both 8 and BMI, the zero order correlation value is less than 2. So the VIF value is below 5, indicating that there is no material problem.
Assalamualaikum warahmatullahi wabarakatuh. My name is Nur Zakia binti Sufia, metric number 8182907. I will present about conclusion. In conclusion, the report description collect data from datasets of a life insurance with 1,338 observation. Records show the number of age. Each weight class has a different frequency, a relative frequency, and a different cumulative frequency. We achieve our objective to perform a descriptive statistical analysis of data from a data life insurance with 1,338 observation. This includes some very true conclusion, such as description, mean, mode, median, range, and everything related to statistical analysis. Several graphs, such as histogram, bar graph, pie chart, and ogive graph are used to show the frequency clearly. That's all from me. Thank you.